You guys remember this? So, first, to understand what went wrong with this thing, we have to actually see the circuit. Now, this may be a little bit hard to see the circuit diagram, so I'm gonna draw it out for you. So I think that I thought of this more as water flow instead of a circuit. In a water flow, you can shoot water as many times as you want through as many little crevices and indents, and it'll never have to meet back at the center. In a circuit, everything has to lead back to the battery at all times, and in this circuit, it does not. So in this circuit, first you have to turn on the switch, which puts the current into a button, and it doesn't actually reach back to the negative side of the battery. The only reason that that this could ever work is if you push all 3 buttons and flick the switch at the same time, and it wouldn't even work that well. What I was thinking was that with this, you could charge the capacitor by only pressing one of the buttons and the switch, and then you could just release the energy by pressing one of the buttons connected to the coils. Now, I actually don't know if this would have worked or not, but it couldn't have because the battery was only 9 volts. I think that I could have come up with a much better circuit and have a much better power source by just using some simple engineering science. So, magnetism is generated when electricity passes through copper wire. The next part that we're going to have to take a look at in a lot more detail is the capacitor. This was the pride and joy of this project. So what a capacitor does is it stores extra energy and then it can release it. So I just made this capacitor here out of some tin foil and paper towel and wire, and I'm not going to show you how to make it because it is a bit dangerous. Alright, so this capacitor can handle 16 volts. Maybe I should have left its wire on. So I'm going to charge up this capacitor. Did you see that shock? That means that the capacitor is working. So it's strange that, the solder is making it difficult to read its current voltage. But on the multimeter, it's currently telling me that it has about 9.5 volts, and it looks, when it's discharged like this, pretty shocking. And yeah, that's what I was hoping to happen, except on the EMP. So let's see how we could do the same effect with a better circuit. So I've recently just found this notebook out of the depths of my closet, and I've made a new entry. So this entry is about capacitors, and it's basically everything that we just discussed with this circuit diagram. Now, what this circuit diagram will do is it will allow us to do what this could not. One of these buttons will charge the capacitor, and the other one will release the energy. Now, let's check that out in more detail. Okay, so first we start at the input with the battery. And so, with this circuit, the positive side will always be feeding into everything, no matter what. But nothing will work until the buttons are pressed to get them also connected to the negative side. So, As soon as you start pressing the first button, then the capacitor will charge up. After the capacitor is charged, you do not need to press that button anymore, and you can just press the other button, which will release all of the capacitor's energy into the output, which in our case is going to be the copper coil. Okay, it's time for a really fast run through. So, number one, both positive and the negative connections on the battery must be connected to the capacitor in order for it to charge. Number two, as soon as the plus and the minus come into contact with each other, the capacitor will discharge all of its energy. These are connected in the model, just to point it out though. This is a doo-doo circuit because the capacitor never charges. Sadly, I think that this video must come to an end. This video took a lot longer than I was expecting to make because I had to scour the internet for things that might be even better than what I thought in my original circuit. I was originally looking at boost converters, but that idea was far too dangerous because these things increase output tremendously. They can turn about 3 volts into 30,000 volts, which you should never do anything like that because it's super dangerous. There were lots of other circuit diagrams that I also explored, and I wanted to keep 2 coils at the start, but then I realized you might just want to go down to 1. I am going to be making a prototype of this design in my next video, because I just really want this video to get out, and I just realized a few days ago that I passed 300 viewers. And I was around 100 viewers when I first made this, so it'd be pretty cool if I remade it at 300 viewers. So I think that that marks the end for this video. In the next video, we're gonna be, like I said, building a better version of the EMP, which will hopefully work, and at least give us a little bit of measurable output. See you in the next one, guys.